So let's look at using heats of combustion to do heats of reaction calculations. So this is how a substance would react with oxygen to form the basic combustion products for complete combustion. So CO2 as a gas, SO2 as a gas, nitrogen gas, water as a liquid, and if there's any chlorine, HCl, in the aqueous form, it will come out with the liquid water. Now, this is only going to work for combustible reactants and products. But if you have those, then you can use Hess's law and heats of combustion. And what you find is that Hess's law says that it's going to be the sum of the reactants minus the products for the heats of combustion. Now, it's very important that you do pay attention here. The H2O formed is going to be liquid. If you want a vapor to be formed, then you're just simply going to add N sub I, the number of moles of the water, times 44 kilojoules per gram mole. If you'll check, that's going to be your heat of vaporization, so how you're going to change from liquid to vapor. Let's look at an example. In this case, I have C2H5OH as a liquid, reacting with CH3COOH as a liquid, to form another liquid, C2H5COOCCH3 and H2O. All of these are going to be liquids. And we want to do this calculation using heats of combustion and then also using heats of formation. So I first need data. So we have all of our data. In this case, they were just easy to look up. And I calculate the heat of reaction by taking, now then with heat of formation, I use the products minus the reactants. And in this case, we get 35.07 kilojoules per mole. It's not exactly the same, but it's very close, and typically it's going to be within 1% or less of each other. So as I did before, let's take a moment to look at those formation reactions just to confirm that we agree with these, this use of Hess's law. So for the first one here, it's carbon as a solid, hydrogen as a gas, and oxygen as a gas to make C2H5OH. Similar compositions Okay, so what we'll see is that if you take these minus these, I'll have 4 carbons canceling on each side. I have 5 hydrogens on one side and I have 5 on the other. I have 1.5 oxygens on each side, and so I do indeed end up with this minus this to get the correct form of the reaction.